Hey gang, so this is going to be a pretty fast video on linear transformations. You can stop it, rewind it, or pause it as needed. I'm going to go pretty fast through this. So I'm going to start off with something called the parent function. Now the parent function, we're going to write it, if you've got this piece of paper, I've got the white and then the graph, and then I wrote linear transformations over here. You can write it however you want, but we're going to start off with something called the parent function. Now the parent function, just like your parents, a lot of times people say, oh, you look just like your mom, or you look just like your dad. All linear functions look the same. They're all straight lines. They start with y equals x. That's the parent function. Or, since we are using the terminology function, we're going to say f of x for function notation equals x. This is the parent function. What do you know about your parents? Well, I can say this because I'm a parent. We're kind of plain. We're kind of simple. And if you look x, there's nothing added to it. It's kind of boring. Parents, we're kind of boring too sometimes. At least our kids tell us that. F of x equals x. That is the parent function. It is very basic. Okay, so what does it look like when I graph it? Well, if I were to graph this, y equals x. So, sorry, all my cat fur is all over. So, it would go through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And you're like, wait, Miss Dean, where are you getting that? If I were to graph it, if I were to do -2, -1, 0, 1, and 2, y equals x. So that means if x is -2, y is -2. -1, 0, 1, and 2. So I'm going to graph those. If you don't have a ruler, you may want to go grab one. I'm using this little straight edge I have. I'm going to always use blue, which I know it's kind of hard to tell that that's blue, but this is blue. This is f of x, or the parent function. I'm going to graph it a lot today, and it's always going to look like that. 0, 0, 1, 1, 2, 2, 3, 3, every time I graph it. Transformations are when I take this and I twist it, move it, do things to it to transform it into a new graph. So we're going to start off, and I'm going to say, what if I have f of x, meaning my parent function, and I add something to it? Okay, leave a little bit of room right here to write, because we're going to write something right there. If you already wrote really close, we'll write it over here. Okay, so let's give an example of this. What would this look like? So an example would be, if I start off with f of x equals x, the parent function, and the parent has a baby, and the baby's name is g of x, and you're like, oh, that's so sweet, what a name. It is the parent function, which is x. I need to add something to it. So I'm going to say, what if I add 3 to it? What does that do? So the nice thing about parent functions and graphing and everything is transformations. You can do them on your calculator. So I'm going to say, here's my parent function. I'm going to hit graph. It's going to graph it in blue, and that's why I try and use blue on here. Now, if I go back to y equals, and I say, okay, what if I have a baby, and the baby is x plus 3? What does the new graph look like? Oh, so here it is. It started here, and it transformed up 3. So let's actually graph that. So the parent function is 0, 0, 1, 1, 2, 2, 3, 3. Use your straight edge and let's graph it. You like my straight edge there. And then the new function, which I'm going to do in red, it simply moved up 1, 2, 3. Same slope. Everything else was the same. It just transformed up 3. Well, so it looks to me like if I add something, it would move up. So we're going to call this a vertical translation. The word translation just means to move. We typically don't say, oh, I moved to Denton. Or we say that. We don't say, I translated to Denton the other day. Yeah, we don't do that. So when you're talking about translations, you talk about what happens. What's the result? What is the result of f of x when it's transformed into g of x? The result is that g of x moves up 3. Now, if I want to do this more mathy, I would say that g of x translates, that's the mathy word, up 3. If I want to be mathy about it, I'm going to use the word translate. Okay, so that's a vertical translation. Now let's look at another one. And again, I said I was going fast, so you can go back and, oh, I just messed that up. Okay, I'm just going to do this. Sorry. My papers are going to be messy. F of x, and this I'm going to say plus k. Now, I want you to take note. I'm going to make them a little darker. Notice that it's f and then parentheses. I don't have my whiteout handy. Actually, I'm going to look and see if I had it. But I don't think I do. Yeah, I don't. Okay, you're just going to have a little paper there. A little mess. What happens when f of x plus k? So this one on the end, you just added a k on the end. What if k is inside the parentheses? Now, I'm going to tell you a quick little story. I'm going to talk about parentheses. See my little heart there? X and k are in love, okay? They are together. Here's the problem. When they break up and x becomes k's x, they go to the mall, or x goes to the mall, and he's hanging out, I'm going to do it as a guy, he's hanging out with some other girl. And Kay goes to the mall and she sees him. And she's like, oh, what? You're with somebody else. And I know, yes, the argument can be made that they're broke up. But anyway, they go back to school the next day. Kay approaches X and she says, hey, I saw you at the mall with that girl. And X, her ex, says, I wasn't there. And Kay's like, yes, you were. I saw you. And X is like, nuh-uh. Because we know that our exes, you know what? I'm stereotyping here. They are liars. Exes always lie. So he's like, I was not at the mall. And you're like, yeah, it was. So I want you to think about it this way. And we're going to make a note here about exes. They exes always lie. I'm going to put an S. I think it needs to have an S. Exes lie. All right. So what does that mean? We're going to do this. Let's put an example down here. So you're like, okay, Mrs. Dean, I'm totally not following you. I want that to be in blue. Sorry. F of x equals x, because that's my parent function, has a baby g of x, and g of x looks like this. F of x plus 2. Okay, now here's what I know. I know that x's lie. I know the parent function is 0, 0, 1, 1, 2, 2, 3, 3, and so on. I've kind of got the hang of that. I'm going to graph it. After a while, you won't really need a straight edge to graph it. You'll be pretty good at graphing it. But here's what I know. X lies. X says that it is a positive 2, that it's moving positive 2. If you're moving positive 2, when you're moving with the x, you are moving horizontally on the x-axis. Move horizontal. On x-axis. Okay, but here's the deal. X's, oh my gosh, they always lie. So I'm going to draw an arrow here. Those X's lie. X says it's moving positive 2 on the x-axis, but it's lying. It's actually moving negative 2. So I pick any point I want and I move back 2 units horizontally. I could go to this point and move back 2. I could go to this point and move back 2. Whatever I want to do, I just move back. And there's my line. It is, what's the result? The result is that g of x moved. Now, it says it moves positive 2, which is this way, but I know x's lie, so it moved left 2. Or, I'm going to use that mathy word, and I'm going to say g of x translated left 2. Okay, so I want to do a couple of examples to see if you're getting it. So up here I'm going to write the word example. I'm going to give you that f of x equals x, g of x equals x minus 2 plus 1. I want to know what is the result. Now I'm going to tell you that there are 2 transformations that happen. Sometimes it helps to graph it. Sometimes it really doesn't matter if you graph it. 0, 0, 1, 1, 2, 2, and so on. That is my, oh, there was a little glitch in my table right there. There's my parent function. Now, let's talk about this. Without graphing it, let's look at it. I know that when you're in that relationship with the parentheses, that means you're moving with the x. That's a horizontal movement on the x-axis. Oh, but x, he's a liar. So x says he's moving to the left, -2. I know he's lying. What's the result? He moved to the right, not the left. How many? 2. And then you can't do you can't do one movement without the other one. The +1 on the end, it's not inside the parentheses, so that's just out here on the end. So that means it's going to move up 1. So we need to do all of those movements together. Pick a point. I almost always pick the origin. I need to move to the right 2, so 1, 2, and up 1, so it's right there. I could pick another point anywhere on the line, go to the right 2, and up 1. Any point you want you can use. You just need 2 points to graph it, so right here it is. And there's my new line. Okay, let's do another one. I'm going to do, again, slow it down, watch it again if you need to. I'm going pretty fast. It's not a super hard concept. Okay, this time I'm going to use function notation. And I'm going to do x plus 3 minus 2. I want to know what the results are. And I'm going to tell you there are 2 transformations. I'm going to go ahead and graph my parent function while you look at that. 1, 1, 2, 2, 3, 3, so on. All right. When I move here, I'm in that relationship inside the parentheses. It says it's moving to the +3, but those x's, when they're in those relationships, they lie. And so I'm going to say that I move to the left 3. The -2 on the end, I move down 2. So I'm going to start at 0, 0, and I'm going to the left 1, 2, 3, and down 1, 2. I'm going to pick another point. I'm going to go left 1, 2, 3, down 1, 2. And there those are. All right, I'm going to turn my paper over on the back side. Now I've kind of got it reversed. I've got the graph and then the white, which is fine. It doesn't matter. All right. Oh, did I put a name on that? Oh, I did not. Okay. So we had a vertical translation was what we did on that one. And we're going to call this one, because we're moving with the X, we're going to call this a horizontal translation. This is the horizontal translation. If you have a highlighter, you could highlight that to kind of make it stand out. I don't have a highlighter handy. I don't think. I do have a yellow marker, so I might color that in, and then I might color, oh, it's probably going to smear on mine. Color that in. All right. Also, if you want, I do have copies of this. And if you give me your copy, I will give you my copy. I just want to see that I did a valid attempt to try it, and you took your notes. And then I will trade you. But you need to show me your copy with these notes on it, and then I'll give you a copy of mine. All right, let's do a reflection. Reflection is like a mirror image. So I'm going to take the parent function, 1, 1, 2, 2, 3, 3, 4, 4. And I want to reflect it. Now I want to reflect it over the y-axis. Okay, I'm going to reflect it over the y-axis. When I do, all it does is it takes the parent function f of x equals x. The baby, g of x, is simply reflect the x. Just negate it. If it was positive, make it negative. If it was negative, make it positive. So it's going to be, let's think about it like this. If I have -2, the opposite of -2 would be +2. -1 would become 1, 0 would become 0, 1 would become -1, and 2 would become -2. So it goes back the other way. -1, 1, -2, 2. And you might even say these lines are perpendicular. The reflection of it would be perpendicular. All right, so let's put that the results would be that g of x is reflected over the y-axis. Okay. Now we're going to do another one, a stretch and a shrink. Okay, so we're going to have a vertical stretch, and then next to it on the other side, I'm going to do a vertical shrink. Okay, when you stretch something, think of that like if you have a fat little piece of bubble gum and you stretch it, it gets smaller, right? It gets more narrow. Shrinking is when I take that Coke can and I smush it down and it compresses it. And when you smush it down, it kind of gets wider, right? It kind of goes bleh and gets a little bit bigger. So, parent function, we're always going to start with that parent function. 1, 1, 2, 2, 3, 3, 4, 4. Parent function on both. This is going to be an a and then f of x. And a vertical shrink is going to look just like that, a f of x. Parent function starts the same on both of them. 1, 1, 2, 2, 3, 3. There's my parent function. So what am I going to do? So here's what it's going to, our example is going to be f of x equals x on both of them. But the baby, here's what's going to happen with the baby. G of x. And I just want to point out, you can have babies with different names, right? Because you guys all in my class have different names. So the parent function, f of x equals x, I could have a baby g of x, I could have h of x, I could have s of x, I could have t of x, I could have m of x, I could have any baby with different names. I'm just choosing on all of this to use g of x. That's the most common one that you'll see me use. All right, so here's what we're going to have. The first one is going to be 3. A is going to be 3, and then we're going to have times f of x. And we want to know what the results are. This one over here, we're going to have 1/2 f of x. Okay, so what I'm saying here is that a, this letter A, is bigger than 1. And on this one, I'm saying A is between 0 and 1. Numbers that are between 0 and 1. Let's just talk about that a minute. Numbers that are between 0 and 1. Well, 1/4, 2/3, 5/6, 7/9, 0.5, 0.88, 0.21359. Okay, so you're going to have a lot of decimals, a lot of fractions. But what you're not going to have, what about 5/4? That's bigger than 1. So this would fall under A is bigger than 1. I could have 22/19. That's bigger than 1. I could have 1.100. That's bigger than 1. So pay attention when you're looking at this. It could be a fraction, but if it's bigger than 1, then we're falling into that first category, this vertical stretch. If I'm over here and I am a fraction or a decimal between 0 and 1, then I'm falling under the shrink category. All right. I want to interpret this because sometimes that function notation is like, what? Can you just write that a different way? Okay, 3 times f of x. F of x is x. So I'm just going to change that to 3 times x. I'm going to graph that so you can kind of see it a little better because I think it's just, this one is just easier to see when you graph it. So I'm going to say 3 times x. So there's my parent function, 1, 1, 2, 2, 3, 3. Now watch what f of x does when we have g of x. Here's g of x. If you were a snow skier, which hill would be more dangerous, in my opinion? Yeah, the red one, the new one. Because Here's my hill, going good. Oh my gosh, look how steep it is. It got super steep. This one you're like, ah, coming down. So I'm going to say what the result is that g of x got steeper. And I need to say by what? By a factor of 3. And I'm going to get my red pen and I'm going to draw it. I'm not going to worry about plotting the points. I'm just going to draw it steeper. Okay, this is my g of x. G of x got steeper. So if this one got steeper, what do you think this one's going to do? It's going to look like this. Okay, so this one, it got less steep. So I'm going to say that my result is that g of x got less steep by a factor of 1/2. Okay, how can you remember that? How can you keep these straight? Well, here's what I do. I think about this fraction right here, and I say that fractions give me a headache. I don't care for fractions. Fractions give me a headache. They make me want to lay my head down and take a nap. So when I have a fraction, I want to lay down or get less steep. That's how I remember it. But you got to be careful because you don't want this fraction right here or here to throw you off. So when you have a fraction between 0 and 1, they give you a headache and make your head hurt, make you want to lay down. All right, so let me give you some examples down here. So let's put the word example. Let's take it home. F of x equals x. G of x equals 3f of x minus 2 plus 1. What are the results? Now pause your video if you want a chance to do it. I'm going to work them out right now. I'm going to tell you there are 3 translations. Pause your video if you don't want to know what they are yet. I'm not even going to graph it. I could, but I'm not even really worried about it. All right, I know the easy one is this plus 1. That simply moves it up 1. I know that when I'm in a relationship, in parentheses right here, with the x, I know that x is light. It says it's moving to the negative, but I know it's really moving to the positive, so I'm going to say that it moves right 2. And then I'm going to look at that 3 right here and say, oh yeah, that 3 is bigger than the number 1, so it's getting steeper. So I'm going to say steeper by a factor of 3. If I were to graph it, it would look something like this. It would be up 1, to the right 2, and I should do that one red. Up 1, to the right 2, and steeper by 3. So I think it's going to be about right there. Up 1, right 2. I'm going to graph that one. I don't want to mess that up. So here's what I'm going to do. I'm going to go down here. I'm going to say 3 parenthesis x minus 2. And then we're going to go up 1. Let's make sure I got that graphed right. There's my parent function. When I start doing the steeper and stuff, I always kind of go back to my calculator to kind of graph it. And there it is. So I'm going to go to second table. I'm going to pull some points off. So there they are, -5, 0, -5. So 1, 2, 3, 4, 5. And I'm going to do that one right there. 1, -2. This column is my parent function. So 1, -2. Over 1, down -2. Let's see if my point would have been on there. There it is. How did I put it in my calculator? 3, x minus 2. You see where I just left that f off basically, and then plus 1. And there it is. A lot of times I don't ask you to graph it. I just want to know what's the transformation. All right. So I hope that helps you. You've got a worksheet now that you're going to do that goes over more of these, and there is a video on the worksheet as well.